this video, we will discuss about height of binary tree after subtree removal queries. You are given the root of a binary tree with n nodes. Each node is assigned a unique value from 1 to n. You are also given an array queries of size m. You have to perform m independent queries on the tree, where in the ith query, you have to remove the subtree rooted at the node with the value queries of I. It is guaranteed that queries of I will not be equal to the value of the root. Return an array answer of size m, where answer of I is the height of the tree after performing the ith query. So what they are saying is that in the question, you are given a binary tree and an array queries. Now what you need to do is that for each of the query, you need to remove the subtree, which is rooted at a particular value in the queries. And then whatever will be the new height of your binary tree, that should be the answer corresponding to that query. Meaning, this is 6 here, right? So what you need to do is, in your binary tree, wherever node 6 is present, you need to remove the subtree which is rooted at node 6. What it will be? This much, right? So this much part has to be removed from the binary tree. Then from the remaining nodes, whatever will be the new height of this binary tree, that will be the answer of 6. Then next is 4. So for 4, if you see that it is present here, right, then that means we need to remove the subtree which is rooted at 4. So it will be this much part, right? So then whatever is the remaining binary tree, whatever is its height, that will be your answer for 4. So first of all, let us find out the height of all the subtrees in this tree, right? So if starting from here, for this 9, what will be its height? There are no nodes below it, right? So height is basically nothing but the number of edges in the longest path in that tree. So for example, for this one, you will see that this is the longest path. So how many edges are there? 1, 2, 3, and 4. So the overall height of this tree will be 4, right? Right now, we are identifying the height for all the subtrees rooted at a particular node. So for this 9, we don't have anything below it, right? So for this, what will be the height? 0, right? Then for node 8 also the height will be 0. Then for node 2 also the height will be 0, right? Now if we check for 7, so for 7 we have this much part, right? So only one path is there which is having edge 1, right? So its height will be 1, right? Then if you check for 6, then this also will be 1, and for 3 also it will be 1, right? Now if we check for 5, now for 5 there is only one path which is having 2 edges, so its height will also be 2. Then for node 4, you will see that we have two paths. One is this one, which is having 2 edges, and one is this one, which is having 3 edges, right? Which one you will take? Height is always the number of edges in the longest path. So you will take this one, right? So you can see that the height of this node was 2 and the height of this node was 1, right? So out of these two, whichever is the maximum, that will be considered, right? And because we are adding one more node here, so see, the height of this node will be 1 plus maximum of the height of left subtree plus the height of right subtree, right? So if you will see here 1, here 2, maximum is 2, so 2 plus 1, 3. So the height of 4 will be 3. And then similarly for 1, here we have 1 and here we have 3. Maximum is 3, so 3 plus 1, 4. So the height of this will be 4. So now we have the height of all the subtrees in our binary tree, right? Now let us see. So initially the height of this tree is 4, right? Now they are saying remove the subtree rooted at 6 and tell the new height. So if you remove this much part, what will be the new height? The new height will remain the same, right? Because still the longest path is having 4 edges. So height will remain as is. So for 6, the answer will be 4, right? Now if we check for 4, then all of this part will be removed, right? What is the remaining part? There is only one path. There are 2 edges in it. So the new height of the tree will be 2. For 4, the answer will be 2, right? So here if you see, whenever we are removing a subtree rooted at a node which is present in the longest path, at that time the height of the tree is changing. And whenever we are removing a subtree which is rooted at a node which is not present in the longest path, so let's suppose this 3, 2, 6, 8, then in that case, the height of the binary tree remains as is, right? So now we cannot identify whether a particular subtree is present in the longest path or not, because that will take a lot of time for us. The number of nodes that are given to us is 10 to the power 5 and the number of queries are 10 to the power 4. So if you will do this, it will be 10 to the power 9, which will be too long and it will give you TLE, right? So we cannot identify or we cannot remove a subtree at each of the query and then recalculate the height, right? So we will have to do some pre-computation beforehand so that for all these queries, we can get our answer in constant time. Okay. So now what is that pre-computation? How are we going to do it? What is the intuition? So let's understand that first, right? So now if you see here that if I am at node 5, meaning I need to remove this subtree, right? Then in that case, all the other nodes are remaining as is, right? All the other nodes are not being touched at all. So if you see here, when I am removing this much part, then this part is always remaining as is, right? These nodes will always remain as is, meaning whatever is the contribution of this much part of the tree in my height, that will remain as is, right? It's just that when I have removed this part, then that means this much contribution has been changed now, right? So what will be the new contribution? What will be the other nodes that will be participating in calculating the height? These nodes, right? So what I'm saying is that when I am removing this part of the subtree, so this part is removed now, right? So for calculating the new height, you will consider these parts, right? But if you see in all these three, this part of the subtree will always remain the same, right? We are not removing these. So if you see here, if I am at node 5, meaning I need to remove this much subtree, right? So now if you see earlier, the longest path was this one, right? So this part of the tree was contributing in the height of my tree, right? Now when I have removed this, then I need to calculate the new height. My height will change now, right? Because this was the longest path. So now how you will identify that what will be the new height? Now you will see that, okay, now this particular part is removed. So then that means the longest path has changed now. So from the remaining paths, you will see which one is now the longest. And then whichever will be the longest, that will be your answer, right? So out of these two, you will say that, okay, this one is the longest, right? And in this, the height is 3. So the new height will be 3, right? So what we did, that whenever a subtree from the longest path was removed, we knew that the height is going to change. So we checked that now what is the next longest path in the remaining tree. With the help of that, we identified the new height, right? And the next thing that you can note is that for this 5, when you remove this 5, this part was removed and this part will always remain as is, meaning the contribution of this part will remain the same no matter if I remove 5 or 6 or 2, right? So now when I'm saying that the contribution of this part will remain as is and I am removing node 5, then you just need to know that now from this remaining part, now how many nodes are present in the longest path, right? So this part was removed. So we are left with only this path and this path, right? Now out of this one is the longest, right? And its edges are 1, or we can say the height is 1, right? Now you know that for this the height was 2 and here you got 1. So 2 plus 1 height is 3, right? So what I'm saying is that when you are removing node 5, then this part is removed and now the new contribution will be of either this part or this part. And then you will identify which is giving the maximum height, that one you will choose, right? Now how are you saying that you will check for 2 and 6? Because all of these are at same level, right? So levels meaning this is level 0, this is level 1, this is level 2, this is level 3 and this is level 4. So levels are nothing but the depth of a particular node from the root node. So this is the root node itself. So for this the depth or the level is 0. For these two they are one edge away from the root node, so their level or depth is 1, we can say that, right? So when you are removing node 5, then that means the above levels, level 0 and level 1 are as is, their contribution is as is, right? But when you are removing node 5, which is like level 2, then that means level 2, 3, 4, their contribution is going to change now, right? So how will you identify? You can check what all other nodes are present at this particular level. So you will see node 2 and node 6 are present, right? Now you will see out of this, which one is giving you the maximum height, right? So you will see, okay, this one is giving the maximum height, right? So that you will consider as your answer. Now at each point, we cannot identify that which one is giving me the longest height, right? Now how can you do in constant time? So if you see when we are removing this 5 is present in the longest path. At that time we are taking this path is our answer. Why? Because this is the second largest path right now, right? And then when let's suppose you are removing this node 6, at that time the height is as is because the longest path is as is, right? So when we are removing from the longest path, at that time we are taking the second largest one, right? So if for every level you know that which two nodes are giving you the largest height and the second largest height. So is it going to work for you? So if you see at this particular level, this node 5 is giving you a height of 2, node 6 is giving you a height of 1, and node 2 is giving you a height of 0. In this, the maximum is 2, right? And the second maximum is 1, right? So you said, okay, I'll consider these two, right? Now you know that whenever node 5 will be removed, then that means I am removing the node which was giving me the largest height, right? So then that means you will consider the second largest now, right? And whenever you are removing this node 2 subtree or node 6 subtree, at that time you are not removing the subtree which is present in the longest path. So longest path is remaining as is, so the height will also remain as is, so which you can calculate through this 2, right? So for every level we would need which of the two nodes is giving us the largest and the second largest height, right? Now this 5 will give you that, okay, I am having a height of 2, and 6 will give you I am having a height of 1. So now how you will calculate the overall height of the tree? So as I said that when you are removing any node from this level, the above two levels are remaining as is. So when we are removing 5, you will use node 6 to identify the height now, right? So you know that it is giving you the height of 2 and it is at level 2. Right, it is at level 2, meaning it is 2 edges away from the root node. So whatever is the height of its subtree, that you know with this one, and whatever is the height above it, that you know with its level. So if you sum up these two values, will you be able to get the height of the new tree? You will, right? So if you see here, when we remove node 5, then we would consider node 6. For node 6, the height is 1 and it is level 2. So 1 plus 2 will be 3. So then that means the new height will be 3. Is it going to be 3? Yes. So 1, 2, 3. Right? Then if you see, if I'm removing node 6, in that case, what will happen? That we will consider node 5 only because it is giving the largest height. In that, the height is 2 and the level is 2. So 2 plus 2 will be 4. And the overall height of the tree will also be 4. So that's what we want to do. That is our intuition. That whenever you want to remove a subtree rooted at a node, then you should know at which level that node is present, right? Then at that particular level, what are the two nodes? What are the two nodes giving maximum and second maximum height, right? So first we will identify that at which particular level that node is present, and then what are the two nodes in that particular level which are giving you the maximum and the second maximum height, right? And also you should know the depth of that node, right? Depth of the node. So if you know these three things, you will be able to identify the answer of your query in constant time, right? So let's write down all these informations and see how are we going to do this. So here it is mentioned what is the height and what is the depth, right? So we'll just write down that for every level what is the, or for every depth what is the maximum and the second maximum height, right? So if you will see, for level 0 we only have root node, we only have one node, right? So its height is 4. Then for level 1 we are having two nodes only which are having heights 1 and 3, so we'll keep 1 and 3. Now for node 3 we have three nodes, 2, 6 and 5. For these, the heights are 0, 1, and 2. Out of these, which one is the largest? 2. And which one is the second largest? 1. So, for 2, it will be 1 and 2. Then if we see for level 3. So, for level 3, we are having only two nodes with the height as 0 and 1. So, it will be 0 and 1. For level 4, we are having only one node with the height as 0. So, we will keep it as 0. Right? So now when we have all these informations, we have the height for all the nodes, we know the depth or the level of all the nodes, and we know the largest and the second largest height for all the levels. We will try to find out the answer of these queries, right? So first is 6, right? Now if you will see, for the 6, the level is 2, right? At level 2, we have height 1 and 2, right? What is the height of 6? It is 1, right? Now here 1 is the second largest, right? Then that means we will consider the largest one, right? Because second largest is being removed, so the largest one will remain as is, right? So the largest one is having the height as 2, right? And what is the level of 6? That is also 2, right? So the answer will be 2 plus 2, that is 4. So for 6, the answer will be 4. Meaning when you are removing the subtree rooted at node 6, the height of the binary tree will be 4. So this part is removed and we have this longest path. So the height will be 4. Now for 4, how you will check? So you will see that node 4 is present at level 1. For level 1, we have the largest height as 3 and the second largest height as 1. The height of 4 is 3. Then that means we are removing the largest one. So we will consider the second largest, which is 1, right? What is the level of 4? That is 1. So it will be 1 plus 1, that is 2. So basically this part is being removed. So only this much will be left, which will be a height of 2. So for 4, it will be 2, right? For node 3 also, you can see that node 3 is present at level 1. For level 1, we have 1 and 3 as the height. Its height is 1, which is the second largest. So we will take the largest, which is 3, and its level is 1. So 3 plus 1 will be equals to 4. So the height of the tree will also be 4. Now when we check for node 9, for node 9, you will see that it is present at level 4. And at level 4, we only have one node, which is node 9 itself. And this is what we are removing. So now when you are removing this node, this entire level will be removed from the tree, right? Because there was only one node in it and you have removed it, right? So only this much part of the tree will be left, right? And in this, the last level is level 3, right? So in the level 3, there will always be height 3, right? If you see at level 3, we have these two nodes. For both of these, the height will be 3, 1, 2, 3, 1, 2, 3, right? So whenever we are removing a particular node from this level, then whatever other remaining number of levels, that is your answer, right? That's just logically, but programmatically, our code will handle this situation automatically. We do not have to explicitly write a condition for it, right? So for 9, the answer will come out as 3, right? And then similarly, we can do for 5 also, right? So now I hope you got a gist of the solution. How are we going to do this? So for finding out all these informations like what is the height of a particular node, what is the depth of a particular node, and at every depth or at every level which is the largest height and which is the second largest height, all of this stuff you are pre-computing and storing it somewhere, and then in constant time you are finding out the answer of all the queries. And all these informations that we are finding out, these also can be pre-computed just in one traversal of the tree. We can do the depth first search in our tree, right? And with that, as you do the depth first search, you will be able to identify the depth. As soon as you move on to the next depth, you can increase your depth by 1. This is how you will get the depth. And then height also, when you will be coming back, when you came at this node, now when you will come back through that, you can identify the height, right? And then for all the levels, you can maintain two vectors which will store the first maximum and the second maximum height. And then accordingly, whenever you are finding out the height of any node, you know its level. In the vectors, you can check where that height can be fit, and then accordingly you can find out all your information, right? So let's code it out now. You will be able to understand better by looking at the code. So what we'll do is that first of all, we will take a variable n whose initial value we will keep as 10 to the power 5. Now, why are we doing this? Because initially we do not know that how many number of nodes are present in our tree. So whatever is the maximum number of nodes given in the constraints, which is 10 to the power 5. So whatever vectors we are creating, we will create it with the size as 10 to the power 5 plus 1, which is n plus 1, right? So now what all vectors do we need? First, we need a vector for storing the depth, right? So we will name it depths. And it will be of size n plus 1, and initially all will have the value as 0. Then we need to create another vector heights, which will store the height. Its size will also be n plus 1, and initially all will be 0. Now we need two more vectors for storing the first maximum and the second maximum height, right? So we'll create a vector which will be first max height. Its size will be n plus 1, and initially all the values will be 0. And then we need a second max height, right? So this will also be n plus 1, and it will store 0 initially, right? Now what we need to do, we need to update all these vectors, right? So we will perform a DFS. We will perform a depth first search. So now what all things it is going to receive? So let's see that. So first of all, we'll create a function here which will be DFS, right? So now what all it will receive? So first it needs the current node, right? So let's name it node. Then it needs to know what is the current level. So it will be int level, right? Then we want all of these four vectors to update them, right? So now inside this, what we'll do? We need to update depths, heights, first max height and second max height, right? So since we know the level here, we know the level. So in the depths, we'll update the level. In the depths, whatever is the node's value, so its depth will be updated as a level, right? Then what we need to find out? We need to find out the height. For height, as I said, what it was, 1 plus maximum of height of left subtree and right subtree, right? So we need to find out what is the left height. So for left height, we will do DFS, and in this, we will pass nodes left, right? Level will be increased by 1 because now we are moving to the next level, right? And then depths, heights, all other things will remain as is. Right now we need to identify the right height. So right height will also be the same. It's just that we will pass the nodes right here, level will increase by 1 and all other things will remain as is. Now that we have got the height of the left subtree and the right subtree, we need to find out the current height, right? So what will be the current height now? It will be 1 plus maximum of left height and right height, right? So then you have got the current height. Now if you will see here, since we are doing 1 plus maximum of left, right and right height, so what will happen here is for every node here. So you will see that for this 9, we won't be having any childs of it, right? So its left height will also be 0 and its right height will also be 0, right? And what is our formula? Our formula is 1 plus maximum of left height and right height, right? So it will do 1 plus 0, which is 1. So for 9, we will get the height as 1, right? So in this particular vector, what will happen is that all the heights will be stored as plus ones, right? Meaning this 4 will be stored as 5, 1 and 3 will be stored as 2 comma 4, 1 and 2 will be stored as 2 comma 3, 0 and 1 will be stored as 1 comma 2 and this 4 will be stored as 1, right? So for finding out the answer, what we were doing, whatever was the height that we are getting out of these two, in that we are summing up the level, right? So we will do minus 1 also in addition, so that this is changed to this, right? So that we'll see in the code. I will tell you at what point we are doing that. So now that we have got the current height, what we need to do is in the heights vector, we will update the height of this particular node. So it will be current height, right? Now that you have got it, you should update your first maximum and second maximum height also, right? You know the level of this particular node, with that you can update, right? So you will check that if the current height is greater than the first maximum height of this particular level. If it is, then that means you should update your first maximum, second maximum height, right? So whatever was the first maximum height at this particular point, that will become your second max height, right? So second max height will be equals to first max height of this particular level, and the first max height of this particular level will be equals to current height, right? Otherwise, if at any case our current height becomes greater than the second max height, then that means we should update the second max height of this level to current height, right? So this will also be level, right? So this is how we can update it. And at the end, we need to return the current height. Why are we returning current height? Because see, in DFS, we are getting the left, right and right height, right? So whatever is the height of the current node, that you should return. So this void will change to integer because we are returning integer. Now what will be the base case for this? So the base case will be that if at any point your root becomes a null pointer, right? If your root becomes a null pointer, in that case what you will return? You will return 0 because there are no nodes, there is no height, so we will return 0, right? So now that we have done the DFS part, we have updated all the 4 vectors, we'll come back here. Now here what we'll do in DFS, what all we need to pass? First we need to pass the node, which will initially be root. Then we need to pass the level, which will initially be 0, right? Then we need to pass all our vectors. So now we'll create a vector which will store our results, right? And now we will loop inside our queries. So this will give us a node. So now first we will identify the level of that node, which will be given by depths, right? So depths of node will give you the level. Now we need to check that is its height equals to the first maximum height or the second maximum height of that particular level. So if heights of node is equals to the first maximum height of that particular level, then in that case the answer will be second max height, right? So in results we will push back level plus the second max height of that level. And since I told you that all the heights are being stored as +1, so we'll do a -1 here, right? So that we can get the correct answer. Now, if it is not equals to the first maximum height, in that case, our answer will always be first maximum height only, right? So in results, we will push back level plus the first maximum height of that particular level -1, right? And at the end, you can simply return your results, right? So let's try to run this now. So our test cases are accepted. Now let's submit this. So it got accepted. Thank you so much for watching. Please subscribe our channel.